Okay, dear students, in today's class, we will discuss about the hybridization. Let's see the hybridization. Here, this hybridization, here onwards, we represent this by the HY, just for understanding. Here, the formula to calculate the hybridization is half of V plus X minus C plus A. Now, here, in this V is nothing but the valency, number of valency electrons. So here the V is the number of valency electrons and here X is the number of monovalent atoms. Here X is the number of monovalent atoms. Mono means one. So those atoms which can form one bond, we take only those atoms. So here the example for this one, you can take the hydrogen. Hydrogen can form the one bond, as well as you can take the halogens, bonded halogens like the fluorine, chlorine, bromine, iodine. Now C is nothing but the cation. So it is the charge on cation, and here A is the anion. So it is the charge on anion. So here V is the number of valence electrons, X is the number of monovalent atoms. So those atoms which form only one bond, we consider only those number of atoms. C is the cation, charge on cation, A is the anion, charge on anion. Now let's see how to calculate the V. Let's see how to calculate the number of valence electrons. For this, you need to know the electronic configuration. So you know the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. With the help of this configuration, you can write the electronic configuration for 2 plus 2, 4, 10, 12, 18, 20, 30, 36, 38. For 38 electrons, we can write the electronic configuration. So this is enough for us. This information is enough for us to solve the maximum numericals. Okay, now let's see how to calculate the number of valence electrons. For example, if you take the beryllium atomic number is 4, electronic configuration. So 4 means 2 plus 2, 4. We take the 1s2, 2s2, 2 plus 2, 4. The electronic configuration for beryllium. For example, if you take the carbon, atomic number is 6. 6 means 2 plus 2, 4. We need more 2. We take from here. So the configuration will be 1s2, 2s2, 2p. So we have taken the 1s2, 2s2. From this 6 we take the 2. 2 plus 2, 4. 4 plus 2, 6. Now here we have to know how to calculate the number of valence electrons. So here this is the second shell, it is the first shell. So second shell is the last shell, that is the valence shell. The number of electrons in it known as the valence electrons. So here the valence electrons are 2. Here the second shell is the last shell. In this 2 plus 2 we have the 4 electrons. So here we have the 4 valence electrons. For example, if you take the oxygen atomic number is 8, electronic configuration 1s2, 2s2, 2p, 4. So 2 plus 2, 4, 4 plus 4, 8. So here number of valence electrons, second shell is the last shell, 2 plus 4 we have the 6 valence electrons. In the same way, if you take for example, if you take the phosphorus number is 15, configuration 15 means 2, 4, 10, 12, we need 3 more, so we'll take the 3p3. So here it is 1s2, 2s2, 2p6, 3s2, 3p3. So 2, 4, 10, 12, 15, 15. Here third shell is the last shell. In this we have the 2 plus 3, 5 electrons. So here the V is 5. For example, if you have the sulfur, number is 16. So 16 means 2, 4, 10, 12. So 12 plus 4, 16 means we need to write 1s2, 2s2, 2p6, 3s2, 3p4. So it is the 2, 4, 10, 12, 12 plus 4, 16. Here the third shell is the last shell. In this we have 2 plus 4, 6, means valence electrons are here 6. So this will be the useful information for us in further explanation. Now let's see few examples. For example, if you take the H2O, in this let's say we need to calculate the hybridization for oxygen. So you know the formula for hybridization, it is half of V. So just now we have seen oxygen is having the 6 valence electrons. So V plus X, X is the number of monovalent atoms. So here we have the 2 hydrogens, 2 monovalent atoms, so we take the 2. Now we don't have any charge, so we close the brackets. So 6 plus 2, 8, 8 by 2 means 4. So here we have the 4. 4 means S, P1, P2, P3. So here hybridization will be sp3. Here this hybridization value, if we get 2, so here the 2 means sp, hybridization will be sp for the value 2. Let's say if you get the answer 3 here, then 3 means sp1, p2. So it will be the sp2. If you get the 4 as we got just now, it is the sp1, p2, p3. So here 4 means it is the sp3. How we are getting this one? We know we have the one s orbital, we have the 3 p orbitals. It is the s orbital, these are the p orbitals. If you take the d orbitals, how many d orbitals we have? We have the 5 d orbitals. Now let's see, okay, how we got the sp for the 2 here? sp, 3 means sp1, p2, sp2. 4 means sp1, p2, p3, sp3. Now let's say we have the 5. So 5 means sp1, p2, p3, d1. So sp3d or dsp3, both possibilities. So if you have the 6, 6 means sp1, p2, p3, d1, d2. So it is sp3, d2 or d2, sp3. Now mostly we come across this type of hybridization. This you will get in coordination compounds. So when we discuss about the complex or coordination compounds, there we will discuss about this type of hybridization. Now we concentrate on this particular type. Now let's see the example of NH4 plus. So you know the formula, it is half of V. Nitrogen is having the 5 valence electrons we have seen just now, plus X is the number of monovalent atoms. We have the 4 hydrogens, so we take the 4. V plus X minus C. C is the charge on cation. So here we have one positive charge, so we take here 1. So 5 plus 4, 9, 9 minus 1, 8. 8 by 2 means 4. Again here the 4 means sp1, p2, p3. So it is the sp3 hybridization. Now let's take the I3 minus. Here this I3 minus is, this is the I3 minus, 3 iodines. So it is the negative charge. This iodine is the central atom and these two are bonded atoms. Okay. Now we need to calculate the hybridization for this one. So here formula half of V. You know iodine. So iodine belongs to the halogens. You know halogens are having the 7 valency electrons. So here V plus X, number of monovalent atoms. Bonded atoms we are having the 2. So V plus X minus C, we don't have the positive charges, plus A. So charge on anion. So we have one charge, one negative charge. So 7 plus 2, 9, 9 plus 1, 10. 10 by 2 means 5. So here 5 means sp1, p2, p3, d1. So here hybridization is sp3d hybridization. Now let's see another example. For example, if you take for example XeOF4, here xenon hybridization we need to find. Let's say for here we can calculate by half of V. You know xenon belongs to the inert gases. You know inert gases are having the 8 valency electrons. So here we take the 8, V plus X. X is the number of monovalent atoms. Here we have the fluorine and oxygen. You know fluorine is the monovalent atom, oxygen is a divalent. So we don't consider the oxygen here. We have the 4 fluorines, 4 monovalent atoms. So we take the 4 here. V plus X. So here minus C. Okay, here we don't have any charges. Directly let's close this one. So here 8 plus 4, 12. 12 by 2 means here 6. 6 means S, P1, P2, P3, D1, D2. So S, P3, D2 hybridization. So like this we calculate the hybridization. Now let's see how to calculate the hybridization in case of organic molecules. To know this, you should have some idea regarding the bonds and hybridization. If you have the single bond, then we take the sp3 hybridization. If you have the double bond, then we take the sp2 hybridization for those double bonded carbons. If we have the triple bond, or if you have the carbon, both the sides of carbon, if you have the double bond, in these cases we take the sp hybridization. So for sp hybridization we have the two cases. Triple bonded carbons, we take the sp hybridization, as well as carbon both the sides, if we have the double bond, we take the sp hybridization. The reason is very simple. We count only sigma bonds, we don't count the pi bonds. Okay, now let's see the example. Let's see, here we have the double bond, here triple bond, then let's see, here is the double bond, double bond. Okay, now you know carbon can form the 4 bonds. Carbon is tetravalent. So here carbon is 1 bond, means obviously remaining 3 bonds with the hydrogens. So by default, whatever the number of bonds less, we take the hydrogens. Now carbon is having 1 bond. So 1 bond means we take the sp3 hybridization. Carbon single double. So double bond means we take the sp2 hybridization. So carbon double single. So we give the importance to the multiple bonds. So carbon double bond means here we take the sp2. Carbon triple means we take the sp. Carbon triple means we take the sp hybridization. So carbon single double. Double means for double we take the sp2. Now carbon both the sides double bond. Carbon both the sides double bond means we take the sp. So carbon double bond. So carbon double bond means here we take the sp2 hybridization. So carbon single bond means it is a sp3 hybridization. Like this we need to take the hybridization. Now let's solve the previous NEET as well as the JEE questions related to the hybridization. Okay dear students, let's solve the previous NEET question. Here they are asking, in which of the following pair both the species have sp3 hybridization. So we need to identify which one is having the sp3 hybridization. So if we take the sulfur, okay, let's use a formula that is half of V. So you know sulfur is having 6 valence electrons. So V plus X, number of monovalent atoms are 2. So here 6 plus 2, 8. 8 by 2 means 4. 4 means sp3 hybridization. Now here boron hybridization we need to calculate. So it is a half of, if you take the boron, boron is having the 3 valence electrons, 1s2, 2s2, 2p1, 2s2, 2p1, 2 plus 1, 3. So it is having the 3 valence electrons. V plus X, number of monovalent atoms are 3. So 3 plus 3 is 6, 6 by 2 means 3. 3 means here it is the sp2 hybridization. sp3, sp2. So different. They are saying the pair both should have sp3. So both are different. So it is a wrong option. Let's say this particular option. So it is a half of, you know, silicon. Silicon belongs to the carbon group. So it is having the 4 valence electrons. V plus X. Number of monovalent atoms are 4. So here 4 plus 4, 8. 8 by 2 means 4. 4 means sp3 hybridization. Now here beryllium hybridization we need to find. So it is a half of V. So beryllium is having how many valence electrons? Beryllium means 1s2, 2s2. It is having just 2 valence electrons. So V plus X. So 2 monovalent atoms. 2 plus 2, 4. 4 by 2 means 2. So 2 means it is sp hybridization. sp3, sp. Both are different. We need to identify pair with the sp3. Let's take this one. So if you take the nitrogen, you know nitrogen is having how many valence electrons? 5. So V plus X is the number of monovalent atoms. We are having the 3 fluorines. So you take the 3. 5 plus 3, 8. 8 by 2 means 4. 4 means it is sp3 hybridization. Now let's calculate for oxygen here. It is half of. Oxygen is having the 6 valence electrons. Number of monovalent atoms are 2. So here 6 plus 2, 8. 8 by 2 means 4. So 4 means sp3. So sp3, sp3 both are having the sp3. So it is the right option. Let's see why it is wrong. So it is half of. Nitrogen is having the 5 valence electrons. Number of monovalent atoms are 3. So 5 plus 3, 8. 8 by 2 means 4. 4 is sp3. And if you take the BF3, here it is a half of. Boron is having the 3 valence electrons. And here number of monovalent atoms are 3. So 6 by 2 means 3. 3 means it is sp2. So sp3, sp2 different. So this is a right option. Like this we need to solve the question. Okay, let's solve this particular question. Here we need to identify the order of hybridization. This particular sequence we need to identify from left to right. Let's see. Here carbon is having the triple bond, means it is the sp hybridization. So carbon triple means it is sp, carbon triple is sp, and it is carbon triple means sp, triple bond means. So here the same sequence we are not getting from left to right. So it is not the right option. Now let's see this one. Carbon double bond means it is sp2 hybridization. So carbon double bond is sp2 hybridization. Carbon triple bond means it is sp hybridization. Carbon triple bond means it is sp hybridization. sp2, 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 sp and sp. Same sequence. So it is the right option. Let's see why these are wrong. Here carbon single bond means it is sp3. So carbon double means it is sp2. So carbon double means sp2 and this one is sp3. So not the same sequence. That's why it is wrong. Now here carbon double bond means sp2. Carbon double bond means it is sp2. So carbon double is sp2 and here also carbon double bond means it is sp2 carbon. So not the same sequence. So that's the wrong option. So this one is right. Okay students, let's solve this previous JEE question. So we need to calculate the hybridization of nitrogen in these. So here nitrogen, it is half of. Number of valence electrons are 5. Here oxygen is divalent atom. We need to take the monovalent atoms only. So we don't take these divalent atoms. So V plus X minus C, we don't have the positive charge, plus A, we have one negative charge. So here 5 plus 1, 6. 6 by 2 means 3. So 3 means it is sp2 hybridization. Now here if you take the nitrogen, it is half of V plus X. Number of monovalent atoms are 0. V plus X minus C. So positive charges 1. So 5 minus 1, 4. 4 by 2 means 2. 2 means it is sp hybridization. Now let's see the nitrogen here. It is half of. Number of valence electrons are 5. V plus X. Number of monovalent atoms are 4. V plus X minus C. Number of positive charges are 1. So 5 plus 4, 9. 9 minus 1, 8. 8 by 2 means 4. 4 means sp3 hybridization. So here nitrogen hybridization in this species are sp2, sp, sp3. So sp3 not sp. So it is a wrong option. So here sp3, sp it is also wrong option. Here it is sp2. No, it is also wrong. So here sp2, sp, sp3. Yes. So it is the right option. So like this we need to solve the question. Hope you understood this one. Okay, all the best to all of you.